Cool. Okay, so today we have with us Richard Booth, who wrote a really interesting book about doing advanced math on the Timex Sinclair computers. And with that, Richard, I'm just going to hand it over to you and let you run the show for a bit and tell us about yourself and your book and what caused you to do such a crazy thing.
Okay. So yeah, so I promise this won't be very technical at all.
Oh, darn.
And um, I'm honestly, I'm just getting back to, I went through the book again and thinking, okay, what was I thinking when I did that? So there's some of that going on. What I can do is I'm going to share some kind of random slides here, and let's see, it's in the PowerPoint. So let me know if it comes out okay on your screens.
Yeah, I can see it fine.
Okay. All
And
right.
you came prepared, I'll tell you.
So what I did is I stole kind of the format of these slides from my employment presentation. so um, so that's why it kind of looks the way it does. So the book is, as I think people know, the Applied Sinclair Subroutines and Programs for the Mathematically Minded. I hesitated in calling it a retrospective because it had a very limited run. So I'm just going to say this is a perspective from years later. And again, I was amazed that, again, that this activity is still kind of going on, which indicates that this is a very strong kind of beginning of the home computer era. And I don't know if Sinclair could claim that fame or not, but it was kind of it really happened very suddenly. It got me involved because, and I think they did it deliberately. They made these things ultra cheap and just so affordable that you couldn't resist buying the things. So that's what I did. I was kind of involved in computers in college. So it wasn't like the first time I'd, even touched anything like that. But, it was the punch card era and, these tapes you ran through tape readers and things like that. So these home computers, I think, were just like the best idea ever, because it got, a lot of people kind of thinking they could do it too. So, okay, what the book is, it's a book of routines really for engineers and applied mathematics people. And it came really, this is kind of the profile of what it is. It's subroutine oriented. So the idea is that you can have a set of subroutines that can get called by the programs, which turn out to be like these demo routines. And in this kind of basic, if you're going to do that, you need to have the subroutines play together in terms of the variables that they need. So you can't overlap. You have to be very careful about how you're mapping it. It's a global namespace, but that's fine, and it makes it sort of like you can use any subroutine in any other subroutine. And that's the way it was oriented. Is that you could put them all into memory at the same time and run them and run the demos.
And your book is very actually good about explaining which subroutines require which variables, and so it's not like you're working in a blind. So
Yeah, I'll explain later. One thing that really got me, and that was one of David's questions, is what kind of made me put this together. And yeah, I don't know. I mean, I have a slide on that. So basically, I saw somebody else's approach, and I didn't think it was very good. So I thought maybe I'd give it a try. So the demos, they do give an explanation of what the sort of idea of the mathematics is, and then suggestions for doing more. So the kind of idea there, I guess, is sort of like an educational thing, or so somebody just wants to play around with this stuff. This is really my intention, not for like, any computer course or anything like that. It's more or less, yeah, you can do this stuff and you can learn this stuff, and it's kind of fun to do that. what I did, and this is one reason why I think this is a much better first approach, is it had this val function, and anybody that's used that said, oh yeah, that's how you can do much more complicated things, which you could not do on all the other like the Commodore or the other kind of basic computers. So val more or less allows you to write a string which is going to do some calculation and then have it evaluated. Another thing that I kind of realized, I was looking over the book just now, and or just recently. It really does assume that the reader has some knowledge, maybe not extensive knowledge, but some knowledge of what the subject matter is. So it's, I guess you could say, it's not trying to talk down to you, it's more or less trying to get you involved and get you to play with this stuff, even though you know some of the material already. And I did make a deliberate effort to do more than might be expected. So for example, in the differentiation routine, I did a general order as opposed to just like a single differentiation kind of routine. So you can do, second order, third order, or nth order differentiation. In the nonlinear regression, most books would probably stop at just linear regression. But nonlinear regression is much more challenging and probably much more useful in some cases, because most things are nonlinear. So, it's kind of an interesting thing to get into. And then this multiple precision calculator where you can just keep, as many digits as you want, which I don't see any big practical use for that, but it's kind of fun to do that. I mean, it's make a calculator that goes out to lots of precision points. So, I mean, the comment here is that this was a very early home computer with basic. So many other kinds of basic that I worked with, for example, on the HP calculators, had a little bit more structure, if then else, and if, and things like that. And but this was really a very innovative basic, in my opinion, very well put together. I really thought it was very good. And in the 1980s, when things were just starting out, what happened with publishing the book is I did approach a couple of publishers, and it took a long time. This is with just like a little bit of writing and saying, okay, what do you think about doing this kind of thing? So of course they took a long time, and eventually said no. And I forget exactly what the reasons were, but they said, well, there are books already and things like that, which there were. There were some books that were out there. Or, it could be that the market just wasn't ready for this kind of thing. Maybe it was, again, at this point, it wasn't really terribly figured out. So it could have been anything that they wanted it to be, However, what happened is it had really no extensive editing, which really goes into any publishing effort. Maybe it shows. I don't know. So a lot of it, yeah, going back a little bit clumsy sometimes, but there it is. Anyway, so I published it myself. It was a self-publishing effort, and there was a university publications that I used. And I forget what the original, I think it was maybe 100 copies or maybe even less than that. And I put some advertisements in the Timex Sinclair magazines. Got a review or two. And so I sold, not too few, but not too many books, about 120. And eventually kind of pretty much broke even on the costs. That's that. So like I said, it was a pretty short run and kind of fun to do. I mean, I didn't think that it would really turn into anything that exciting in terms of like a big publishing effort, but it was a fun exercise to go through. So,
hey, Richard, Adam has a question. I don't know if you can see when.
Oh, I'm sorry. Yeah.
Yeah. I didn't want to interrupt you. It's if you're, go ahead if you're not
Oh
done with
no,
the slides.
please, anybody, I was going to say
Okay.
this, anybody just please interrupt.
Oh,
I'll-
okay.
I'll look.
Well, my question is, you were saying the publishers, they said they weren't ready for it. But I know that, you know, once Timex pulled out of the market here in America, I'm guessing that they were, because your book came out in '85.
Yeah.
Like, is that when it was it, were you sending it off to publishers before Timex went out? Like, or probably not, right?
No, this is, I'm trying to remember, the time frame was like a year before, maybe a year and a half before. I was like saying, I could do this. And so I guess I don't exactly remember what I sent to them, but maybe like a chapter or something. Say, what do you
Okay.
think about this?
I guess my big question is, like, if Timex wasn't around anymore, I could see why any publishers would have hesitated
Yeah,
to publish it. Yeah. And also, like, were you part of a local user group where you were sharing this information and maybe bouncing ideas back and forth between users?
not a bit. No, there was
Oh,
no,
really? That's interesting to know.
not that I was aware of. Yeah,
Yeah.
Okay.
yeah, that
And
might have been helpful. Yeah.
yeah, well, I was really impressed by actually the writing style, because you talk about in the beginning of the book how you start off each chapter with something corny, and I don't really think your jokes are corny at all. I think I think nowadays they might sound like dad jokes or something, but that's the jokes I say, so I think that's okay. Like, for instance, one of the things you say is something along the lines of, because some of them take a long time to run, some of the plots, and like you said, well, in your free time while you're waiting for your computer to plot, maybe you can write a letter to your congressman or something like that, you know, which is pretty amusing. And so I'm glad you have a good sense of humor, because otherwise the subject could be pretty dry.
Yeah, yeah, yeah.
Yeah,
In fact, it is quite dry.
yeah.
Yeah.
But I don't think I've come across, and I'm a stickler for like good grammar and stuff. So your grammar and everything is fantastic.
Oh, that's
And
good.
I read a lot of self-published books, and that is not normally the case. So yeah, if the market had been a little bigger, I'm sure you could have gotten this book published pretty easily. Yeah.
Yeah, I was. Yeah, I mean, I didn't have any big expectations, but it was kind of disappointing because I had seen a couple of books already, and it's like, okay, why don't you publish another one? Anyway, but I didn't try that hard, admittedly, and I was like, okay, I'll just do it myself.
And you enjoyed writing it, I assume, because that's
Yeah, you know, and I wrote it on. I didn't write it on a word processor. I had a typewriter, so all that's like on a. Trying to remember the brand of typewriter. It's like it wasn't edited. So in other words, it just came out the way it was.
oh, good job then. Good typing skills.
I just had these copied. So, and that's why, you know, a lot of it, you know, it's like handwritten stuff. Anyway, so
And these were these Xerox copies, by the way? Like all the copies you sold?
yeah, in the publishing center, they put it through a massive, you know, Xerox copy and bound it.
I have a question about, so were you in school? Because the address, was it you know, at the university, when it was a specific lab?
Yes, yes, it was at yeah, graduate school,
Okay.
High
Okay.
University.
Okay. Did you get any, you know, people must have sent the orders to you at the lab?
I think, yeah, as I remember, yeah. So we had you know, at the office downstairs. I think I got the orders right there.
Yeah. Okay. Interesting.
If you have the copy, Dave, you have the copy in the back. There's
Yeah, the red card.
yeah, the red card for if you find any mistakes. I never got anything back, but I'm sure there were mistakes.
Should I send them there?
Yeah, please. If I'm not answering questions, it's probably not because I'm seeing hands go up, but yeah, please just interrupt anytime, please. So these are kind of the questions, Dave, that you had sent, some of them. What led me to write the book? Well, I think I've already gone into a little bit of this. At the time, I was taking this course in numerical methods, and it was a really intensively hard course. But in a sense, it kind of really turned me on to kind of some of the aspects that are very interesting in these kind of it wasn't really in computing, but it was in numerical methods. And some of those were, I applied in the book. The second thing is I saw that, there was this kind of, I forget where I first saw it. I have the book, a book on numerical software in BASIC for the Apple II. And in my opinion, it really wasn't very good at all. It had some very technical programs, regression, but a lot of them were just not very general. It had to do with like specific fields in engineering. Nobody's going to just use those in a general way. And what's more is it didn't really hold together. One chapter had nothing to do with the next one. And they didn't have like any adequate explanation of what's going on in the program. They just give you the program. So I thought, okay, well, I could do better. I think that would be a good thing to do. Before that, any hands? I had written a couple articles for the Sync magazine. One was the Game of Life and Assembly Code, and then the next one was the curve plotting graphics, which I thought, okay, well, that would be a good start for a book. And it has the aspect of not being too dry and uninteresting for the average person. So a lot of the book does revolve around that second chapter on.
Right. It also gives you immediate feedback. Like you have step-by-step directions in a table, and you enter the information, and bam, seconds later you start getting a little plot. And the first ones you plot take like 30 seconds, so it's not so bad at all.
Yeah. So it's sort of structure-wise. I mean, and in fact, that second chapter used the sort of very simple vector routines in the first chapter. So I don't know, that kind of fit together in a sense, doing it in that way. And I guess I could say I wasn't really, I was trying to remember exactly, but I thought educational software for teaching mathematics would sort of catch on because of all these home computers, especially the graphics aspect, which I thought was pretty cool. I don't think, I could be wrong, I don't think that's exactly how they're being used in schools now. I'm not sure that's the best way. But on the other hand, if you had kids learning stuff and taking control of it and just doing it the way nobody was telling it to do it, then I think that would really turn them on to mathematics. Anyway, it's kind of interesting in my mind to compare it today with back then, in the sense that I've been watching these things on YouTube. There are lots of mathematical things that people getting with graphics, and it's just amazing. Vertasium, and there's a just numerical YouTube channel that just talks about strange things in mathematics alone. And I think that's really cool. And I understand that a lot of teachers do use that stuff. So I think it's in a sort of roundabout way, this sort of thing has caught on a little bit. What was challenging to implement? I think the multiple precision operations thing was pretty challenging. I think it's the longest routine in the book. But I think that's one of the coolest ones. You can take pi out. And also the nonlinear regression, which there are lots of variants of that in really numerical analysis. So just choosing one of those. Did I have interactions? Not many. I met this guy at a local event. I became friends with him, and I learned that he had actually bought my book. He's a machinist, so he was interested in building CNC kind of things.
Richard. Hello, my name is Gustavo. I am in Buenos Aires, Argentina. I read your book on 86 approx, when I started at the university, the first degrees of engineering in electronics. And I remember I use your book as a base to create a polar plot diagram used for Smith for match impedance. And also your book is really very clear and has a very good application with the basic, because on those years is one of the most useful language in the computer. It's not Pascal or whatever. Just basic at the university or at the school is the main language for those days. And I remember I use your book as a reference for my plot in high resolution using the Sinclair, because I need to create the the school problems or whatever different solution, and use your book as a reference for matrix and also for Lisa Hughes and other applications. I really appreciate it. You see here at the meeting after 40 years. Yeah.
Thank you.
Richard, this is what I'm talking about. You know, there's Gustavo's not exactly new to the meetings. He's been coming for a while, and you know, he's in Argentina. He's been in Argentina his entire life. So this is how widespread the community is.
Yeah.
And enthusiastic.
Yeah. Well, thank you. And
Gustavo, did I hear you say you had this book in 1986?
Approximately, yeah. Because
Wow,
I have a friend of mine that he lives in UK, and also sent to me a copy. I don't have the copy now, but I read the book mainly 86, 87, no more than this.
And Richard, did every copy of the book come with the tape?
I think I think probably most of them I sent with a tape, but you could order it without the tape.
Okay.
I think that there probably were a couple that didn't buy the tape. Like,
and also Adam, one of another my resources for computer on those time is because I'm amateur radio. I have a connect with different people worldwide on those years, and also I have a long distance communication with the US, UK, and different places.
Okay.
That's why I got the information maybe, and sometimes I transmit in Argentina one of the first computer communication made with the Sinclair. I created a specific protocol for audio protocol. Before that, the Timex created the modem, because I use a radio to send and receive programs by an RF transmitter.
Oh, that's incredible.
Yeah, 84, 85 maybe.
Wow. That's really cool. Thank you, Gustavo.
Oh, thank you.
Thanks. It's great to hear when somebody actually does use these things. And like I said, I mean, I didn't hear many people come back and say anything like that. But when I did get one review in the Sync magazine that's it was pretty complimentary. It was didn't say they had to put it to use, but it said that they liked it and so forth. So that was nice. What's more is, I guess I make the point. I have used these routines when I work today. So some of them are quite useful, like the changing base routine. The regression you can use anywhere, but some of these have been somewhat useful in other projects. Yeah, I thought I would just put it like a little bit of a blurb on the Timex Sinclair Basic, which was, again, very early basic, intended for home computer use. I don't know what they thought about how people would use these things. I just don't know, because they were so new. So I don't know if they had an idea that people would, I don't know. I mean, do some graphics on the screen or something. I really don't know what they were thinking. Other than, here's the first thing that you could, type in things and have a response. So anyway, from today's perspectives, here are some strengths, very small list, maybe, of strengths and weaknesses. Again, I was very tuned into this evaluation of string expressions and the val function. So that's a very elegant thing to do. And it's sort of, it's an idea of a program generated code, and it can be very elegant. In other words, I even do this, in other programs today. If you're going to write some data out to disk, it's kind of interesting to write it out in the same language as the program that's writing, because then you can say, just execute that code that you wrote out, and then it's no effort to write parsing routines or anything. So I think that's a very elegant thing to do. I understand that, I think I've read in it like Python. I use Python a lot. That maybe you shouldn't be doing these things for maybe security reasons, but and I don't know if it's a bad coding practice, but a lot of people get very opinionated about this kind of thing. So, but I disagree. I think it's actually kind of a good thing. Other basics that I discovered, I don't know about today, but I don't know how popular BASIC itself is today. But at least at that time, they didn't support that string evaluation, and it was a big shame. This BASIC has one giant namespace, so you have to force strict naming conventions on variables. Yeah, and you could view that as like, okay, that's just like a little hurdle you got to get through. But it's kind of a pain sometimes. I thought the single keystroke and command entry was really great, because you could rapidly enter these routines, and you didn't have to like have a typing experience. I mean, I could type, but single keystroke was a wonderful idea, because if they're thinking of their first users of these computers, and the fact that you just have to type one key to get a whole entire word out, brilliant, really good idea. In terms of understandability, BASIC has, of course, the advantage of being very simple, simple English keywords. However, it sort of invoked these go-tos and no structure like else or end if. So you tend to naturally get BASIC's spaghetti code if you don't try to avoid it. So, I mean, you can pretty much avoid it if you don't do too much of it, and then it's still readable. For branch labels or names of subroutines, you have to use variables to do them, which wasn't a big deal. And again, I use these routines in other languages. Of course, I did that because they're really not hard to translate.
Well, before you continue, I did want to mention something. I don't know how recently you read your book, or if you reread it in preparation for this or anything. But one of the first things you mentioned, and maybe even one of the first paragraphs, is that that your program isn't written for speed. And there you'd mentioned like it's written for readability and usefulness. And if you want something to be faster, there you have some ideas at the end of the book, which I haven't gotten to yet. So I guess they're there, I hope. But I did think it was interesting that you told the reader right away that this is to help you learn and make it useful to you. And if you're looking for something to be very fast, you want to go to something else, maybe machine language or such, or just rewrite it in BASIC in a different way.
That's true. I mean, if a lot of times these kind of programs where people are really trying to optimize a lot of it, it tends to become non-understandable. So it's better to be understandable and then modify later, and especially if you're trying to give it as somebody to try to understand it. That's much fun. Looking at it again, like you said, I did read it recently, and I said, well, what is this doing? So But I mean, it's, you know, you can figure it. It's not that hard. So this is what another reason why I got into this stuff is that these are the Timex or Sinclair and Timex products that I got into. And honestly, this is the one that really got me into the Sinclair products. This programmable calculator, I spent hours with this guy. And you could put in small programs, and the challenge was getting it to fit into the number of lines of code that you could put into it. And it was just so much fun. So, and then when I saw this guy, said, I don't know, I think I have to do this too. So, so I mean, looking at this guy from this from today's perspective, I think this went for about $100, you know, back then, and it was just okay. What can you do with this thing? So I just had to try this thing, and once you got this thing, you had to get this thing, because it's just so much. You know, looks much better, I think. And then of course you get into this. Okay, in the U.S. we have the 2068, and this is where I stopped, but. This is where I think that most of the book was kind of based on the stuff that came out of this guy.
Hmm.
Richard, did
This
you
is
build your own computers, or did you buy it already pre-assembled?
I bought this pre-assembled, then I went into a PC, and that was a kit. So I put that together. That was just a DOS. And I guess, you know, that's kind of one breaking point. I guess I got into that a little bit more. And that was kind of fun too. So just a little bit about the book itself and the content. That was one of David's questions, you know, just give a little bit of overview of what's in the book. This is the title. And I should say thanks to Edwin and David for putting this online. So you can just download it now. So no need to order the book. It's in PDF form. And this is what's in it. Just very briefly, I start out with this chapter 1 on vector operations. And again, this is sort of going over a couple of things that you find in engineering, which are discrete convolution maybe, and then finding the basis functions using Gram-Schmidt for the normalization. But some of these routines were used in the second chapter, which I thought was kind of a good, these are the vector norm ones are very simple. And so it's maybe very simple and kind of dry, but at least a small introduction. But then you get into the plotting functions, plotting polar, Cartesian, parametric, and then some special plane functions that are presented. There's a list of those. Yeah, the last one is like plotting contours, like so not quite 3D, but plotting the contours of functions.
Yeah, in fact, I believe it was David who pointed this book out to me specifically because of the really cool way that those contours look. I haven't actually got those to plot yet. I've been running into some errors, but my own fault probably. And I'm into video art from that era, like the cool pictures and stuff like that. And even though it takes a long time to plot it, I think one of your plots, I think, says it takes 6.5 minutes or something.
Yeah.
But nowadays you can run it under emulation. You can have it be done instantly if you want. I just like the way they look. And you have pictures, maybe you'll get to them in the book, that show what you can expect on both the 81 and the 2068, which is a great.
Yeah, that's probably all I'm going to present from the internal part of the book. Yeah, the plots are kind of like the big feature of the book, I guess. So the rest of these, I don't know how well they exactly play together, but they kind of have a sort of a flow. You know, the special functions are also plots, and then the calculus, which I think a lot of people would want to, if they're taking a course in calculus, they might want to try some of these things out. And then matrices, roots and impression, and then differential equations using these kind of routines for solving differential equations. And then finally, the other sort of chapter I'm kind of proud of is this number representation where you have this multiple precision thing, which actually worked out pretty well. And the other one was the base conversion. So it does both the integer part and the fractional part. And last, I put some down at the end here, some one-liners, mathematical constants, and so forth. So, so here are the plots, one from the ZX81 and the other from the 2068. These are the plane curves. And I think one of these actually got on the title, maybe not. The Lazy Joe, as the reviewer called these plots of the Lazy Joe figures. I was like, what's he talking about? Oh, yeah, the Lazy Joe. So yeah, this was again sort of the highlight of the book. That, and then the let's see, the contour plots.
Yes.
So not quite as exciting on the ZX81, but the 2068, which take more time, but they're kind of neat. I mean, they're entrancing.
Yeah, I'm going to try them out some more this week. Hopefully, I'll get them to run, and I'll post some pictures of them on to our groups.io. So.
Okay, excellent.
Yeah.
What else about that? Here's a bio in case anybody's interested. Again, this is sort of a just a very brief covering. So started out university-wise at Carnegie Mellon, and I spent 2 years there in mathematics. Loved it, but decided it's probably not. It wasn't the area that I thought I would probably go into, like applied mathematics. So it was a good lead-in to go into engineering, which I did at the University of Maryland, electrical engineering. Did internship at Harry Diamond Labs in Delphi, Maryland, and then went to work at Westinghouse in Baltimore. From there, I went to Lehigh University in electrical engineering. I focused on device, semiconductor device characterization, and stayed there for a good long time and wrote this book. So that's where that happened. Then I went to Belgium, worked at IMEC. And there I worked in a group that was involved in process and device simulation and optimization. That was very interesting, but I found that I kind of found that it was limiting. They were putting together things that weren't exactly being used that much in the company itself. So I thought I would move on from there, and I came back to America to work for AT&T Bell Labs in Allentown, PA. And I don't know if anybody here has had the experience, but AT&T became many other things. It broke up, and right now it's, I think Bell Labs is Alcatel, and Lucent, I think, is it's still in existence. The gear is no longer in existence. Anyway, so I sort of, without changing seats, I was in multiple companies.
Well, that was enforced by the government, right? That breakup, right?
Well, that was prior to my coming there. They broke the into the baby bells. These other kind of mixtures of companies, they were trying to, I don't know what they were trying to do. They had parts of the company that seemed like they would be a logical separate company. So, for example, the AT&T microelectronics, I guess they just wanted to like separate and go into their own smaller company, Lucent. And at that time, I think they broke up into 3 entities. And then the same thing with the gear. I think that a gear lasted for a few years, and I think it had its issues in terms of like they had many brilliant people working there, Bell Labs people, but they just really couldn't finish a product in my mind. A lot of times they would start projects, and a lot of them just stopped for some, they couldn't get it, marketed correctly or something.
Gear sounded mighty familiar, so I did a quick lookup. Gear got bought by LSI about 2 years before the company I was working for got bought by LSI. And of course,
Okay.
they got bought by Avago.
Yeah, Avago, and now it's Broadcom, I think.
Yep. But I think I left there just after they got bought by Avago, about a year after.
Okay. Yeah, Avago is really, they took the name of the Broadcom. Broadcom is actually better known, but Avago wanted their name, so I guess they bought them and took them.
The fun part was I remember when the Hock Tan, the CEO of Avago, made a comment about how LSI employees were a bit overpaid and you have to bring up the employees of Avago to the same level. And to us, the rest of us go, oh, great. So no pay raise for a couple of years. Wow. He had a way of putting his foot in his mouth.
Yeah. Well, it sounds like some people have lived through the same experience. See, these big companies, sometimes I think they're too big in the sense that they, at least our problem at AT&T is that different aspects of the very same company didn't even know that other parts of the company existed, for one thing. But if they did know, they would start competing with them. So, which, okay, doesn't sound like one company to me. I had the same experience at the very next one, which was Lattice. Lattice is really based in Oregon. And they had, again, different parts of the company sort of just competing with each other. And that's not productive. I mean, it's, really you want parts of the company to work together. Anyway, so yeah, so at Lattice, it was kind of interesting. It was more, it was a spinoff from AT&T. It was one of the parts that did FPGA design. And but I got to work on the parts that do go on these FPGAs, which are PLLs and what we call for the channel, like if you're doing some communication, it's a equalizer, so decision feedback equalizer, which is the DFE thing. Fascinating, and I got to use a lot of kind of programming to do that kind of thing. Then I moved from there. Lattice decided that they were going to roll up the sidewalks in the Allentown area, and so we were all kind of forced to look for another job. So I went to Empyrean, which does DC to DC converter design. But then it's not purely doing those kinds of designs. I got to do a SAR ADC and do a lot of converter characterization, which is very interesting. Just kind of different stuff, and kind of nice to do different stuff. Which actually happened when I went to Cisco, and now we're doing silicon photonics IC design and characterization. And I've done a lot of the design, like I think it's like third generation. I've been there for a while. A couple of the products they didn't, or the sort of design didn't get into a product. But we're currently supporting one product that did go out, and then another one that has sort of had, it's done one respin, and they may have another respin. And so I've gotten into the firmware aspect of that, which is a lot of fun. That's C coding, embedded design, and you get to see the stuff actually doing something which is really neat, which is when we look at data eyes, and you can see them actually change and get better and worse. So that's the
Richard, I have a question. Since you're doing firmware stuff now, is it as important nowadays to keep software small, like even in firmware, or is not now size just doesn't matter?
well, up to a point, we haven't had that issue. We have like I think it's 4 CPUs on this current application, and 2 of the CPUs kind of share the same firmware, even though they're doing ultra different things. So in that sense, it's a little bit wasteful, maybe. on the other hand, you can't go too far, and we were kind of running up to the edge on some of the, the compiled firmware. But I've not, the stuff that I'm doing is it's kind of sprawling. It's got a lot of stuff to do, and the other CPU, actually both CPUs are what these CPUs do is they organize the controls that go into the photonics. So there's a separate chip that does light wave kind of stuff. So they kind of organize the tuning of the light wave stuff, and they do it sort of real time, so it tracks temperature and things like that. So they use but the main thing that is they need to actually send the data signal out to the optics, so it actually does the change in phase on the light. That's the responsibility of the electrical CPUs.
If you could, what are they using to modify the light going through there? Something like a Kerr cell, or?
They call it, what do they call it? It's more or less a capacitor that changes the optical index. So it changes the phase of the light. And they split the light path so that one gets modulated in the opposite sense. So they can make it either constructive or destructive. So it makes a 1 or a 0 coming in.
Interesting.
And also Cisco use SFP. I don't know is a fiber optic adapter on the routers. I don't know if yours say that the photonic are application of this specific module for interface the switches, SFP.
Yeah, I'm not familiar with it.
It's an interface for electric to optic. When you connect a fiber optic to the switch, the carrier switch, you use an adapter, a very, very small adapter. You plug on the switch and also continue with the fiber optic and transmit for long distance. This is one of the application, especially the modulation. When you pass the electrical to optical, you create the different phase or different on and off the carrier, different methods that are using for transmit the data.
Yeah, so like you said, so our method again is it's modulating the light by changing the phase in the light path.
Correct.
And there is what they call these ring resonators. They can also do that, but those are it's another technology that's a little bit more tricky, and we haven't gotten into that.
Yes, a ring and 2 outputs, and also you select the phase.
Yeah.
When you are selected, right?
Yeah.
Richard, do you think having a 2068 would help you with the math on those rings?
Of course it would.
I'll have the 2068. Maybe I'll take it to work someday.
Exactly. I mean, just bring it in as a professional computer and say, look, I'm bringing in the heavy hardware.
Well, I was going to ask if you had done any looking at the slightly extra increased precision that the Sinclair floating point had versus other machines.
No, I can't say no. No, I haven't.
Because most machines used a single precision floating point value, and the Sinclair Basic implemented, and that which was a 4-byte value, and Sinclair Basic implemented a 5-byte floating point. And so instead of like 7 digits of precision, you got like 9 to 10.
Yeah, I mean, I could see that maybe in graphics that might be a useful thing, because like you're saying, these round, especially single precision, that's way too little for a lot of.
Yeah, well, I in my experience back in the day, that it allowed like some matrix routines to work, whereas they wouldn't normally work. on the single precision.
Yeah,
So just-
Sinclair's single precision is a lot like Turbo Pascal's single precision as well. It didn't use IEEE 754. It used its own homebrew 5-byte single precision and had the same advantage in terms of significant digits.
Richard, that was really cool. I didn't think that we would go from, you know, topics that I couldn't wrap my head around when I was 14 to topics that I still can't wrap my head around even more. But there it is.
Yeah, I had one question for you, Richard. You have some really fantastic routines in here. One thing I never expected to see on a 2068 is evaluation of the gamma function. But one thing I did notice is that you didn't put much in. Oh, you didn't put anything in here technically for complex numbers. Were you thinking about that, or was that just something that you didn't think fit in this software?
Yeah, that's a good question. I didn't really know where. I may have had an inkling of that, but I don't think I really explored that.
Okay.
Yeah,
Actually, I
we're-
want to express
yeah.
thank you to both Jeff, who's just talking, and to Richard, because Jeff is the one who typed in the program this past week so that I could actually, well, so all of us could use it, but I happened to use it as well. So without Jeff having typed it in, I would have been like, what? Maybe
Well,
next time.
And one caveat, Adam, is any errors in there are
David's
transcription
fault.
errors of mine.
Yeah. We'll work them out because I still want to continue working on the program and using it this week. So if I come across anything, I'll bring it to the group's attention.
Okay, excellent.
Well, and Jeff, now, you know, I'm tempted, you know, to figure out how to take Richard's especially things like, you know, the contour plots and plot them using your hardware with color, you know, with greater color than you know, the 2068 could do. So Richard, you were, you know, expressing surprise at what folks are doing. Jeff has been working on a FPGA device that attaches to the backside of the 2068 and outputs VGA video by watching the data that's being written to the video memory block. And then he added a bunch of other features. And Jeff is apparently doing this because he enjoys it.
Well, and I wanted an increase in the computational horsepower available to me here. So
So one of the things I want to mention is I get things from all over the place. So for instance, you know, Ed Krampitz found you, Richard, and you know, got a copy of your book and scanned it, and you know, sent me an email and the PDF. And I had indexed 2 articles that you had written for Sync, one on curve plotting graphics, and the other is the game of life in assembly language. So at some point you learned Z80 assembly, right?
Yes, yeah.
Here's the thing to me that, I mean, aside from Ed, you know, going out and finding you, that was left field, is somebody reached out to me, I want to say a year, 18 months ago, to say, you know, I've got these documents from the Westinghouse Timex Sinclair user group. Do you want them? And I said, sure. You know, I whenever somebody says, you know, do you want, you know, print materials, I'm like, yes, I don't care what it is. I'm going to scan it and put it on the internet, right? Because to me, it's part of preserving our community history. So they sent me the Westinghouse Timex Sinclair user group document, and I'm going to just try to bring this up. And so I plugged in everybody whose name was on there, and didn't really think, you know, too much about it, right? I just typed the names in and plug them in. But as it turns out, 5th from the top
No.
is you.
Oh, oh, you know, there are many Richard Booths in the area.
Oh, well, okay, but you did say Westinghouse, right?
Yeah, Westinghouse in Baltimore. This is where is this? 2 and 5 is near Philadelphia, I think, isn't it?
Okay. Okay, so maybe it's a different Richard Booth?
Yeah, in fact, I think another guy at where I used to work, his name was Richard Booth also. So.
Oh, I'm refusing to accept that information. There can't be two Richard Booths.
Real quick, I wanted to point out, so there's a similar book. Let's see if I can see this one. It's
Interesting.
1984. It's numerical analysis, and it's for the TI-99, Commodore, Apple, so on.
Mhm.
So they did. I mean, this was 1984, a year before your book. So they were doing these sort of things. I just found this in the last year and got it.
Yeah.
So they were available. I don't know if they. I don't know. I didn't really see like this in the stores much, but the only scientific book I saw in the stores was Celestial Basic. That was really it.
Mm.
So
Mhm.
That book is interesting. I see, Tim, because it shows on the. Can you show us the cover once more?
sure.
Yeah, like I see it says the Commodore, the Apple, and the TRS-80, which all used Microsoft Basic, but the TI didn't use Microsoft Basic, right? It had some weird variant.
That's right.
Yeah. So I'm curious how the book would have addressed. I mean, I'm getting into the weeds here probably, but you know, it's
I
interesting
think
that
it's just fairly generic basic. What I just looking at something, I'm noticing that it doesn't use let like Sinclair Basic requires. It just had, variable equals
Sure.
such and such. So I think the idea was to be fairly generic. And I don't know enough about Timex TI Basic to know how far it was from Microsoft, how far off. I've got a couple books on basic history. I have to go look and see if it talks about that. But a lot of the American computers manufacturers did actually subcontract with Microsoft.
Yeah.
I mean, Apple, their first version was their own, then they went with Microsoft for their integer their floating point basic. So
yeah, AppleSoft Basic.
and Microsoft Basic really wasn't very good compared to some of the others.
That's why they went out of business.
Yeah. If you look at like, I think one of the best ones early was BBC Basic because it was influenced by Comal. Comal was basically basic in Denmark, but this we got to make this better. So they actually made it to include structured programming, and BBC Basic was influenced by that, and Super Basic for the Kill was influenced by that. But all the US ones, even like the Amigas, the basic was all Microsoft and just really wasn't very good. And Quick Basic wasn't all that great. And then it gets structured programming too much later. So I see we have another guest.
Doggy.
Yeah, I gotta spotlight you, Richard, because we're a dog friendly place here. Oh my God, that's a beauty.
It's her playtime.
Yeah, yeah. Oh, that's awesome. So one of the things that you mentioned at the beginning was how val, the val function, could do all this interpretation for you. And you're correct about that being really unique with with Sinclair Basic. And Ian Logan did a really nice disassembly of the ZX81 ROM. And if you read through that, it's really clear how the val function just uses the built-in interpreter to run whatever you put into it. And one of the things that facilitated was there was a program called ViewCalc, which was a spreadsheet for the ZX81. And early spreadsheets for any of the computers depended upon the functions that whoever wrote that spreadsheet put into the spreadsheet itself, not the functions that were available to to the base within the basic ROM. And with the Sinclair, anything that was available to you as a as a function in Sinclair Basic was available to you in ViewCalc, just because it used that same expression evaluator to do all the hard work, which is a really neat feature. And I've seen it used in all kinds of creative ways in programs. For instance, we've talked about how number requires 5 bytes of RAM for storage, and that's even in like a go-to statement. So if you have a line that says go to 2000, that 2000 is stored as 5 bytes of in RAM. But if you use val to evaluate a string that's 2000, it can actually use less RAM than the number. And so that's what folks did, was that they, in order to save save memory in their programs, they'd be full of all these val statements, and if they wanted 1, for instance, it would be the val of pi divided by pi, which was slow, but it would get you 1.
No, yes,
Well, that is roundabout.
David,
Yeah.
the reason of this is because on the basic program area, the basic lines are stored first with the ASCII value,
Yeah.
like you print, and after that you have a 0A is the token as a number, and then the 5 bytes in binary. That is the format that the number is stored on the basic line. And
Yeah.
also when you use the val, use only the token and the ASCII part, not the binary part.
Yeah.
You need an extra math. Yeah, but of course you gain many bytes in the memory.
Yeah. So there's a lot of cool stuff about Sinclair Basic that's just not in other basics. So you picked the right machine, Richard.
Well, Richard, I think maybe my final question for you is, so after you wrote this book and you were done with it and you said you moved on to other machines, and obviously you talked also about where you worked later. Do you feel like the process of writing this book helped you just in your employment later and just in your general use of math and things like that?
It may have. I was gonna say I've always thought and I actually tell people this. It's always good to have side projects, because when you're at work, a lot of times things aren't going quite right, or your management is not being very good with you. So, there's always good to have a side project that gives you kind of strength, and so that's what it did for me. I had a couple more other side projects always, but this was one that, and I guess it is true that I did use a lot of these in, just knowing what to do with, what kind of calculations you can do. And like I say, I still do have routines that kind of are based on some of this stuff that I do use, today in what I do.
Thanks.
Well, and I found when I was teaching, you never understand anything quite so well as when you have to teach someone. And this book is as much tutorial as it is a tool, which I find very useful.
Yeah, in that sense, writing the book is exercise, in teaching yourself, I guess. It's a good thing to do.
So you showed a Sinclair calculator, and I am terribly curious about. You said it was a challenge to program, and so I'm really curious about that. About what was it like to program? Do you remember much about that?
Yeah, not too much. I just remember I must have spent hours with it. I was trying to calculate the error function and things like that, and just how many lines of code are necessary to do that. I really don't have a lot of recollection about doing that, but I do remember it was just a lot of fun to do that.
I remember there was a book for the TI, I think maybe the TI 59. It's really thick, but about an inch and a quarter thick, on programming it. And I read it when I was 13, and it did not make a lot of sense to me.
When Ryan was over here yesterday, when he pulls out his phone to use the calculator, it's got a TI 59. That's what his calculator is.
And Tim's got a calculator. Show it.
That's the exact one. It's kind of hard to see. It's the.
Oh, is that the one?
Yep.
Oh my
Were those
gosh.
for sale in the US?
No, actually, I knew somebody in the UK. I bought something for them that owed me some money, so they sent me this, and they also sent me the flat screen TV.
Oh, look at that.
So I think this still works. I don't have a battery in it now, but I think I put a battery in a while back and it actually did work. Yeah, no battery, but it did work. The keys are a little on the, they've been wiped out from people touching it. So
Is that 9 volt? Is that what that uses?
yeah, 9 volt.
I hate to put it this way, Tim, but from Clive's early device reliability, I'm surprised it still works.
Yes, I do know that. That some of his stuff was, even the ZX81 had reliability issues. But oh, I want that. So I just got an AC port. I want that's power on the top plug. But anyhow, yeah. So that's what it looks like. That's how big it was. I'm assuming Richard, that's what you had.
Yeah, I think programmable.
Yeah. So it says Cambridge programmable. It's hard to read because kind of faded away a bit. So
Maybe
I think there's still a document out there on how to use it, the user guide.
Oh boy.
Found that.
Well, Richard, that was so cool. And, I did not expect that you had an actual user of your book amongst us. That was really neat to hear about. And, Adam and I are video art lovers, so we're going to be exploring, abusing your code in order to generate video art.
Oh, please do. That was like part of the thing in the book is, please take it further or something.
Cool. Very cool. Does anybody else have any questions for Richard?
I'm curious, is anyone else planning to take a look at the book? Putting you on the spot here, but everyone should say yes.
Yeah, right.
Yeah, I've been looking at it. I've been kind of trying to collect any Sinclair books that are scientific based. There's a couple of them for the spectrum that are really difficult to find. That's why I found the numerical analysis book. I also have science teaching for the ZX81, a UK based book. And of course, I've got the 1000 astronomy book. So there's a few out there, but not many. So I'm surprised I didn't hear about this particular one. So
Tim, hold that one up again. I'm curious to see the bottom portion. Does it see who the author is? Firth and Sparks. How is that book? Do you know? Have you read it?
A lot of interfacing.
Okay.
They spent some time talking about machine code. There's one chapter on computation and mathematical modeling. I think they aim at most for people that want to use it with digital analog type of, instead of having specialty hardware for your science lab or maybe a computer, teaching, you can get a 1000, a little bit of extra hardware instead of spending $1,000 you've got for a couple hundred, the same type of device. Because they do have a picture in there somewhere of like ADD converter. In the back is a number of programs like let's see, a logic gate, logic test, a reaction timer, some stuff in assembly. Something that I've ran across the picture the other day where they show like an A to D converter. So maybe not. Anyhow, so I actually had to order this from the UK because this is a British book. But there's one gentleman who wrote a couple for the spectrum on science. It was I want to say one was on aeronautics or something, and one was on something else. But they're hard to, I can't even find they're mentioned, but I can't find anything online about them.
Huh.
So they may not have been professionally published, maybe minimally published.
So there is another book that I know about that's sort of in this realm. Also, I believe self-published by Alan Wallach, maybe, and Maureen McHale. Came out in 1983. It's called Sinclair ZX81, Timex Sinclair 1000 Statistics, 12 16K programs, including multi-factor analysis of variance. And then it goes
sounds
into.
fun.
I'm sorry.
Sounds fun.
Yeah, right, exactly. And it includes things like independent groups t-test, correlated measures t-test. Don't know what that is. Wasn't covered in my intro statistics course.
Yeah, this brings up a question I have for everyone, Richard included. So, I don't think Richard knows about this, but probably other people here do. In England, there's the big spectrum scene, and they make demonstrations of how to use the graphics, and they move the graphics around really quickly. And it made me think when I was looking at some of these plots, which get plotted quite slowly, that some of the demos nowadays they move things around like in real time, like that seem to be these plots. So I'm guessing they're pre-recorded or have the like everything in tables. Do you know what I'm talking about? These like demos that will show graphics moving around, whizzing around the screen.
Well, a
Like,
lot are done in assembly. For
right, I
speed.
understand that, but still, like they're like so fast, and they're moving around like graphics, like, oh, I wouldn't say like a modern computer, but quickly. And it made me think of and comparing it to the plotting that was being done, and wondering how far things have come in like the last, like then the tricks that people use to get the graphics moving around so quickly over the last 40 years, because people have been programming these systems for 40 years now, which is incredible.
There's some ZX81 demos out there that are quite nice, but I think they come with a source code. You can get the source code to look and see how they do it.
Yeah.
Well,
Yeah,
you
it's
do
all
that
in.
and let us know in the next meeting.
You're the one asking the question. I'm just trying to help you learn how to teach you. I don't want to, give you the answer.
Well,
As my professor once said, or a professor, the proof is trivial.
thing is, Adam, if you don't have pre-canned graphics, you can, if you want to go to the trouble of using scaled fixed point, you can speed a lot of that up quite a bit. But that's something that I've never really gotten into because I just don't like trying to keep track of decimals.
Well, what is scaled fixed point?
That's using integer arithmetic, but assigning, say in a 16-bit number, you can assign 4 bits for your decimal, or for your what am I thinking of?
Fraction.
Yeah, well, maybe 4 or 5 for your fraction, and then the remainder of it for everything to the left of the decimal point. And then if you keep track of all that stuff, you can do all of the computations using, well, in the case of the Z80, not so much, but using the integer multiplication and division.
Huh.
We use that for an A to D converter, delta sigma. So yeah, the fixed point is, sometimes you don't even have a floating point operations, so you have to use integer operations. Yeah, so that's, but you're right, you keep track of where that decimal point is. And when you do one operation, I think you have to move it. You have to be much more careful. It's not like just A times B, it's A times B shift decimal point.
Yeah, the Apollo guidance computer did that for a lot of its computations, and takes a lot more patience than I have.
But I think it probably is much faster being integer operations this time.
Richard, you mentioned that you worked on a SAR ADC. I know what ADC stands for. I believe the SAR is successive approximation. What's the R stand for? I mean, I can also use Google.
I think it's successive approximation register.
Register? Okay. All right. Interesting. I know there's a wide variety of analog to digital conversion methods. If I recall correctly, that the SAR method is fastish.
Well, I mean, it's not as fast as a flash, of course, but flash is much more hardware intensive. SAR generally, divides things up into like, it gradually reduces the conversion, and then you get a final result after you figure out where the the level.
Yeah, the big problem with SAR, if it's a problem, is that the greater the bit depth, the more difficult it gets to design, which is why a lot of most of my stuff now uses Delta Sigma. So
Mhm. Delta Sigma would be much slower in this if it matters. If you're just doing a near DC conversion, then that makes a lot of sense.
yeah, most of my designs were dealing with conversions on the order of 50 to 100 kilosamples per second. I wasn't doing anything like software design radio. So
I think that the SAR, it also can tend to go wrong because it's making a decision. And if you have noise, it may make the wrong decision. So, but in the application that we did, it was actually, it actually worked quite well. And it must mean it didn't have a lot of noise that would kind of ruin a conversion.
Wow. I it'll take me a while to process all this.
If we don't mind, like we have about 45 minutes left, and I was wondering, we have a smaller group than we normally do because I think it's Father's Day, kind of expected that to happen.
Yeah.
But I did wonder if there's anyone here who wanted to talk about anything that's been posted to the group lately, and some of the topics. Like David, you posted that you had you made a mailing list for like selling the items that you have that are extra. You posted that since the last meeting.
Yeah.
That I don't know if you want to bring up anything about that. Like, what else did I note here? Well, Willie's not here, so I guess I don't think Willie. Are you here? You're not here, right?
Willie's not here.
Yeah. So I guess I won't mention. But he, maybe I can ask you, David. He asked about the Time Machine compiler for BASIC for the 2068. Does that compile the BASIC tokens for the 2068 too, or is it only for the syntax of the Spectrum?
Oh yeah,
There
yeah.
is
There's a version for the 2068.
Yeah.
It runs, but it runs.
Novasoft imported it and did it. But unfortunately, I can't get it to work.
Oh, okay.
Well, Tim, which version are you using?
The Novasoft one.
But where did you get it?
Somewhere online.
Okay, so the reason I ask is because I just did that tape within the last week or so. And
It's interesting with the Novasoft, it says Time Machine, but you look at the screen, it's Tim Machine. They left
it's
the
Tim
E.
Machine, yes. I've always
Well,
wondered
they-
about
It's
it.
you should put all
specifically
to
written
me.
for you, Tim.
Yes, exactly. I think it's a version of the HiSoft Basic. So there was also the Zip compiler, ZIP.
Yep.
That was a version of. Let me a second here. Simon Goodwin did a compiler for Spectrum Basic. Can't remember the name of it. That became the Zip compiler. I think at one point I had a copy of that, but never really tried it. Okay, I see the link. I have to try that sometime. We'll also figure out how to save stuff in ZXORUS properly. So
You can't save the tape?
You actually, yeah. So
I've played with it a bit. I've got to sit down and figure. I've had some. I was trying to treat a .tap file or .tzx file to have more than one program.
Yeah.
And sometimes it works, sometimes it wouldn't. Sometimes it would save it, and then I'd try and load it, and it wouldn't. And then I'll restart the emulator, and hey, suddenly that tape has multiple files. So it could be a problem also with the emulator.
That's definitely the weirdest one to use. If you have a way to use Fuse or something like that, try to.
I can't
to
get
get it.
Fuse to run as a 2068. So I've got to
Oh.
dig into that also a bit more too.
Well, so Tim, did you try? And I kind of worked through this a little bit a week or two ago. You can effectively load 2 tape recorders into Sorix. There's like one
Input and output. Yep.
input and output. Yeah.
It actually pointed to the same tape file. That should work, I think.
Oh, I think that
Maybe
would
that's
create a
the problem.
conflict. Yeah, I think that would cause it to get upset.
But you want to load your program from one tape and then save it to the same tape, or do you save it to a different tape? I don't know. It
You
should
have
be
to
able
save
to
to a different
write.
tape. So you have to have one source file and like that's going to be your input and one output file, which will be your output tape. And they have to have different names.
We should, you know, what we should do. We should get
Hmm.
Caesar on here to explain it to us.
Because he
Is he
ain't
the
gonna write no
author?
manual. No one needs a manual. Why would you ever need a manual? Everyone I've talked to says, God, I wish I had a manual for this.
Oh,
I
Richard.
could also try Warrievo. That one, yeah, that one's a good one to try also,
Yeah,
Well, then you're going back to DOS. So
yeah.
which
Yeah.
runs fine in DOS box.
I've never heard of DOS before. Na, 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 na.
Adam the Amiga man.
Actually, there's a particular game board game / computer game I play, runs fine in DOS box. So I'm happy with that. And I got a little netbook that I had problems browsing the web these days, but everything emulation wise, it just everything goes whiz bang. It's not as fast as my desktop, but it's fast enough.
Yeah, I actually used DOSBox for just one thing. And back in 1986, there was a version of Risk, the board game, released for DOS. And if you play it now, like you can have DOSBox run as fast as possible. So when your turn is over, even if I have friends who will use DOS and they don't know anything of what I'm talking about, but we'll play together in person. And so when my turn is over, all of a sudden the other computer players have finished. And back in 1986, it would take about 10 or 15 minutes for the computer players to run, but now it's instant. So
I also used it for there's a program called C Robots, where you write little robots in C and then have them fight each other, and you have to slow down DOSBox, otherwise it's done. You know, it runs too fast. I even ported that to the QL.
That reminds me of, what was that program called where you wrote programs that battled with each other?
Core Wars.
Thank you, Core Wars. Yes, yeah, that was genius, and people are still doing that.
And this was for
Yeah,
DOS?
it was
or-
in,
No,
It was-
Core Wars was an article in Scientific American. You know, it's a description of a virtual system with a limited instruction set, and it was a ring memory, right, Tim?
Yeah.
It went around and around.
the language was called Red Code.
Red
I know
Code.
there's 2 versions for the QL. The one version, not mine, was much better. So
Yeah, Core Wars was fun little system.
Another thing I thought we should bring up during this is it was brought to our attention that we're reaching like capacity for storage on the groups.io. And I was trying to go through that and delete some files and stuff, and I can't even delete my own files even when I'm logged in. Do you know what I'm talking about?
Yeah, I know exactly what you're talking about, because I did the exact same thing. I tried to go and see if I could delete anything, and I thought, I better go download the things that have been mailed. Submitted.
So what is the deal? Do we have to be granted like permissions or something like that?
Yeah, it's another David that
Yeah,
is
I know.
the whatever you call it, the manager, the
Administrator
sysadmin,
or something?
whatever. And maybe he can do deletions. I don't know. But yeah, I'm not able to delete my own stuff.
Yeah. Okay.
Yeah. To answer your earlier question, Adam,
Always full of questions.
always full of questions. So I have that. I did set up a email list on my Andertone website, and a few folks have signed up. And I'm gonna actually start putting stuff up after this meeting. And if you have if it's your heart's desire to own what I would politely call old junk, sign up, so that I'm not spamming all over the place. I just want to spam the right people who want to have things in their hands.
when you said old junk, you're referring to the computers or us?
Yes. Well, yes. Okay, so yesterday I dug out Jim. Remember that Jim March showed us a bunch of stuff. He sent me a bunch of stuff. He sent Stuart a bunch of stuff. One of the things that Jim sent me was this floppy disk system that somebody in the UK developed for the ZX81. This little circuit board, literally about 6x6.
This is back in the day or now?
Oh no, this is back in the day. This is like
Okay.
1981, I would say. And it uses a standard Shugart SA400 disc, and so this came with Jim bought this thing, and he sent some discs with it too. It's clear that he used it to do his, write stuff and store it on a disc with his ZX81. It's a really weird interface in the sense that it has an edge connector that is the mirror image of the edge connector on the ZX81. And you're supposed to use an edge connector to edge connector mechanism according to the diagram to connect it, but it came with a ribbon cable, which I think does the same thing. And I went and read the instructions, and I followed the instructions to the letter, and all I get is a black screen when I turn on my my 81. So I have spent as much time as I care to spend on trying to see if this thing works. And now I wish to put it in, give somebody else the opportunity to enjoy it. 5¼ inch, heavy, like 10 pounds. I mean, I can tell it has not just one of those original full height 5¼ inch heavy floppy disk drive, but it has a heavy linear power supply inside. Giant transformer. You can just feel this is a boat anchor in the making. So that's going to go up, and so it'll be available. And as I said before in our prior meeting, I don't want to put this stuff on eBay because I don't particularly care to deal with eBay, and I feel like it would be more likely to end up in the hands of a speculator than on somebody who has a genuine interest in, playing with it.
Well, I would like to see someone here to get it so they could see if they can put some more
Yes.
time into it and get it to work. Like
Yes.
someone, I don't know if Carl would be interested in that, but like that seems like it would be up his alley. Carl Moses.
Right, exactly. Yes, somebody else.
He's local, so then I can see it.
We hereby volunteer Carl. All in favor?
Yeah, poor Carl. He's going to watch this and go, what? Yeah, so, and then I have extra books. So, if you want dusty old books, I'm going to have those. None of them are particularly unusual, I don't think. I'll tell you what I have that I think that everybody deserves to have a copy of, and that is Frogger for the ZX81. And the reason that I think that everybody deserves to have a copy of it is because I have 38 copies shrink wrapped. They didn't even get opened. That's how good.
Who sent those to you?
Those came from Paul. Paul.
It's not a very good version of the game either, actually. But
let's not speak of the shortcomings of Frogger running on the 81.
Maybe
let's just talk about instead your desire to own a shrink wrapped copy.
Yeah, I'll open it up on air.
There you go.
Let the 81 air out.
Yeah. Well, Paul was Paul and Frank Davis were a company called Mechanical Affinity, and they sold all kinds of stuff. And I think that they must have bought, some surplus from Timex at some point, or one of the other vendors who, bought a bunch of stuff.
I was actually playing just like 2 days ago, playing a game on the 81 under emulation called Fortress of Narzad, something like that. Something that Timex put out.
Okay.
And I was playing it because there's a guy up in I think Canada who's taking it and putting it onto is it the Aquarius, the Mattel Aquarius?
Okay.
I guess I'm not supposed to say that out loud, but I hadn't actually played it on the 81, And I was like, well, I guess if I'm going to play his version, I should know what it's based on. And so I was playing it, and I'm like, this game is not. It looks really good actually, and it runs really fast. So it's obviously written in machine language. And when you list it, it's all just gobbledygook. So
Okay.
it's machine language, but it's not a very fun game. And
Is
it's surprised that someone wants to port it to another system.
is it a graphic game like where you have a map and stuff?
No, it's I'm sorry, I thought maybe you would know what it was. It's a space. You're like a UFO on the left side of
Oh,
the
I know what you're talking
screen,
about.
and
Yes.
there's a baddie on the right side, and he's like supposed to be an alien. But it's 81 graphics, so it
Okay.
looks like I don't know what that is. It's something, something interesting. But it's like all you do is move up and down and fire at it, and I guess it's no. I don't know. It's not very exciting to me, but it's I don't really play 80 games on the 81. I play them usually on the 2068 or Spectrum with the Spectrum emulator ROM.
Well, so the reason I ask, Adam, is because Fred Mackbauer wrote, and I got to think about where he put it. He wrote a game called Dungeons of Ymir,
Yeah.
YMIR, and it looks like a roguelike to me.
Hmm.
Is that right, Tim? Kind of like
Something like that. Yeah. It's a top view of rooms, sort of like Wolf 3D. No, I mean original Wolfenstein, Castle Wolfenstein. Or
Is it
some
like
of the other
Temple of
ones.
Apshai? Like that? If anyone knows that one
isn't
from the
that
80s.
isn't
I
that
haven't seen that one in a long time, so it might be like that.
oh
But
yeah.
it's a top-down look where you can see the walls,
Yeah.
as if you're above the thing. There was another video game that's really popular. I can't remember the name of it in the early '80s. Arcade game that was very similar. I want to say Berserk, but may not be it.
Yeah, Berserk had like a walls that it was kind of like this weird view. Your guy was from the
Yeah.
front, but like
Was
the side.
Berserk was the one that would sit and if it's idle, it would say, "Help me." So you'd sit like 10 minutes, and then you're in the arcade all by yourself, or just a couple people in here. Help me.
Oh, I don't know. I
Come
don't
from.
know. It would say fight like a robot and things like that. Chicken fight like a robot. Oh yeah, I'm not familiar with that.
So look at, I mean, this is from the ad, right? And I've run it in in an emulator.
It does high res.
Yeah, it does high res. It's really quite impressive.
Knockbar did a lot of high res.
And you can design your own mazes.
Oh, that's neat.
Yeah. I mean, it's
And it's
not
been
just that
archived
it's
or
high
it's not
res, but it's
archived?
also got a lot of features in terms of, you can have spells, you can have shields and healing potions and etc.
And
and
this
it-
is archived? Like I could
Yep.
download it or not?
Yep,
Yeah?
right there.
Yeah. Oh, okay.
Yeah, and it looks cool running on an 81.
So I guess it
might-
obviously has to require 16K.
There
so-
might still be his website. Someone to think archived his website sometime back with all
Yeah.
of his programs.
I think so. Yeah.
Oh, it was written in 1986, it said. Huh.
Yeah, he was
Okay.
active really late. Relative, he
Did
was
a lot of
working-
work on the 1500. That was like his primary machine because the 16K built in.
Yep.
10 years ago or so he passed away, maybe a little bit more.
I think it was more than that, but yeah. He was Sinclair News. He started that. That was his thing. Wrote a lot of cool software. He
Remind me what Sinclair News is. I think we've talked about it, but I don't.
So it was a magazine that tended to be more technical in terms of the stuff that it published. There was a lot of hardware articles that were written by John Oliger or Oliger or Oliger or any of those variations that we don't know. And then one of the big ones was that 9918, that attaching the
Okay, yeah,
TI
we talked about that in the last
9918 to
meeting.
the back of the 81. John did the hardware, and Fred did the software, the edits to the ZX81 ROM and stuff to make it happen. So,
Richard, did you ever have any of your hardware upgraded to? Did you ever do any upgrades to your besides extra RAM? Because there's so much weird stuff out there.
No, I really did not do anything that.
And did you get rid of your 81 as soon as you got a DOS machine, or did you hold on to any of that stuff?
I still had
Well,
the.
what are you laughing for?
No, I don't tend to throw stuff away, except
Okay.
I did throw a massive amount when I moved overseas, so I had to get rid of a whole bunch of stuff. I probably did get rid of the ZX81.
The smallest machine you got rid of.
Right. Well, the calculator was smaller.
Oh, that's true.
Yeah, I'm trying to think of what happened to that. I think it broke, so I just had to get rid of it.
It's probably Tim has it now.
And mine came from the UK.
So let's see, some of the other things I wrote down here. We talked about the TV PAL, but Carl's not here, so I guess we won't bring that up. I guess Michael's not on, is he?
No,
Okay.
no, but he
Because he
did
made
that.
the serial port and he got the boards for it for the
Yeah.
2068.
Yeah, I would love to hear from him about that.
Yeah. And yeah, I guess that's basically what I wrote down. So yeah.
Okay. Yeah, that was interesting. That there's a couple chips that, contemporary with the computers that you could choose to do serial with, and he used the Motorola 6850, which was I mean, in theory you can use it with any CPU, because all you got to do is accommodate for whatever it needs. And really the biggest weirdness usually tended to be how you generated the clock for these things. And so he used the 6850. The Tasman parallel printer interfaces used an equivalent Motorola chip that did parallel out, to give you a Centronics printer connector from your Spectrum or Timex. The Timex modem used the Intel version, which was the 8251, I think. And they put it on a couple different ports than the ones that Mike chose. And because those things were so plentiful at a certain point in time, you could buy a bare board of the modem. There was a glut of them. Some folks designed a serial board using that chip from that, or there was also plans to turn just the modem itself into a serial connector. So yeah, I was intrigued that he selected that Motorola chip. It must be one he's familiar with more so than the Intel. Because my inclination would be just build the Intel, put it on the same ports that Timex used, so that existing terminal software would work with it.
That was, well, I don't. He's the one to ask, but maybe
Yeah.
other people here will know. So what is his end goal? He's going to have a serial port.
Yeah.
What is he going to do with it? I mean,
I think I asked him that, and I don't think
Yeah.
I got a clear answer.
okay. Just wondering.
Well, the answer that I got was that he had built it a long time ago,
Mhm.
and that he was sort of interested in recreating it.
I see. Because I like the only time I've really ever used true serial ports on any of my 8-bit computers was in the 90s, and I had an Atari 850, which was like it would
Yeah.
plug into the serial port, well the Atari serial port, and give you a parallel port and a few serial ports. And I would use a no modem cable with my PC, and that was when I was first getting back into the 8-bit computers, and I would use a modem on both sides and use X modem to transfer files I was downloading off the internet in 1997. So like there were some FTP sites that I found that had like software. I was like, oh my gosh, there must be 100 floppies here. It's incredible. And so I was transferring some of them over and trying them out. And it was just, I could do it at a fast speed because I wasn't using an actual modem. I think it still wasn't that fast, because I think the 9600 baud was as fast as a serial port could go on the Atari without getting like additional hardware, but it was fast enough. And that was, so I was wondering if he was going to do something like that. Not that you need to do that anymore, but
Yeah, back in the day, it was mostly modems and printers that people used the serial port for.
right.
Yeah.
Some transfer cables. but mostly modem and printers.
Yeah,
Yeah.
I remember
About a year and a
interfacing
half
serial
ago.
printer. Sorry, go ahead, Jeff.
Oh, I was going to say about a year and a half ago, I hooked up a USB serial port to my 2068 and was using it to transfer files between my PC and my 2068.
So what did
Some
you
people are
use?
still doing it.
What's that?
Mike, what did you use do you use one of those FT 232
FTDI chips, yeah.
Okay. But those are USB to TTL serial. And then what were you using? Were you just bit banging it?
No, I dropped a UART in my FPGA. So
Okay.
and it was operating at like 3 megabauds, so you can save and load programs pretty quickly.
I have to ask, what the hell does 3 megabaud mean?
3 megabits per second.
Oh, okay.
For those of us who are pedantic about these things, baud are signals per second, and in the old teletype days,
Mhm.
stop bits were longer than data bits. So instead of having to just figure out what it all is, just said baud.
Mhm. Yeah, and divide by 8 to get the actual, bytes.
Or 5 if you're using baud O code.
Yeah, right. Or and stick was what, 6? The IBM one.
Started out as 6, and then they moved it to 8.
Okay. But you know what, Adam?
Yeah.
To your point.
I never have a point. What are you talking about?
No, you have a point, and that is, what did you use these things for? And I didn't have one for my Sinclair, but I did for a variety of computers have a 300 baud modem, some of which used a hand cradle,
Oh, really? You had one of
an
those?
acoustic
So
coupler.
you had to have the original AT&T telephone, right? That's not the only one that worked with that.
Well, you say it like it's a surprising thing. Everybody had
I know.
a Bell phone back then.
Yeah. What is it? An acoustic coupler, right, or something like that?
Yeah, an acoustic coupler. Yeah.
I used the acoustic coupler on my QL with a Princess handset, which did not fit. So it'd be real quiet when I was doing data transfers.
Uh-huh.
Remember, the Princess is the one that you pick up and you can do the
Yeah.
thing inside. So it did not fit the coupler properly, but it worked.
Yeah.
Just don't sneeze.
You're right. Or your dog bark, or
Yes. Or somebody else, or the worst was someone pick up the line. What's all that noise? Like, I'm using the phone.
Yep. It was a good way to get dropped.
Yeah, I think I mentioned this on the board, but back in the 80s, I had a 300 baud modem for my Commodore 64, which I was never allowed to hook up because my stepfather, thought it would break the telephone line. And I was like, I can use it. And he's like, no, it'll break the line. You can't use it. So I had a modem.
He was
and
right. I mean,
never allowed to
as
use
far
it.
as Bell was concerned, it was going to break the line.
Yeah.
A friend of mine, he first got his modem and did the thing that most people I knew about their first modem was, all these BBSs. And then his dad a month ago, gee, Doug, why do I have such a huge phone bill?
Oh.
Then it's like, okay, the next month he was real low on his modem usage. But the first month, though, yeah, until the phone bill came in.
But now you could take your pick of USART and hook it up to the 2068 and take that thing that Jeff was talking about, the TTL to USB device, and you could telnet from your 2068 to any of the 8 BBSs that are available on Telnet.
If there's anyone here who actually ends up doing that, like with this new, I would like to see a video of that, because I know that, like you said, there are some that you can telnet to, and I would like to see an old computer do that, like someone using a Timex computer. I'm sure there's other people doing it. And in the 90s, I got a 56K cartridge that let me use my 56K modem with a slip account on my Commodore 64, the cartridge port. And was there a point to doing that? I could use links to surf the internet. No, there was no point to that, but it was kind of fun.
Well, one of the things that I archived within the past week or so was Z-Term 64, which is a 64 column version, I think, of M-Term. And it works with, requires the OS 64 cartridge. So, building a little serial port based on the modem wouldn't be too difficult. And then I've got about 5 of the things that that Jeff was talking about. You somehow acquire these if you buy 2 Arduinos. They send you 3 programming cables with it. Yeah, level 29. I don't know if you guys have ever heard of it, but level 29 is probably the best known.
Yeah, you posted a link to that, and I did log in because you can log in just through their website.
Yeah.
Mm-hmm. Write it out, and I wanted to leave a message in the bulletin board section, but I had to create an account, and I'm like, I'm never going to actually log into this thing again, so I didn't create an account. So
that's quitter talk, Adam.
So we have like about 10 minutes left or so.
Yeah.
Maybe do we have any special guests coming up next time, or does anyone we should try to look for or anything like that?
Well, so I tried all of John Oliger's phone numbers, and all of them are not working according to the internets. However, I have been able to get a hold of Jeff Street, and Jeff Street was a programmer that worked for Zebra Systems. He's the person that wrote OS 64, the 64 column cartridge for the 2068. So I need to reping Jeff to see if he's available. I am tempted to see if we can get Cesar, the person who wrote Zsorix, to come join us, and because he did post a comment on one of our videos where we had used his emulator for the.
Oh, did he really? What did he say?
Oh, just that he liked our choice of emulator.
David?
Yeah, go ahead, Gustavo.
Hi. Can you ask these people for Zebra if work with the operating system to adapt the Timex FDD interface for the Timex version, the silver? Because they have used one variable internal, just is different with the Spectrum version.
I wonder. I have no idea, but
I don't follow
Jeff
that question. What do you mean, Gustavo?
Yes, the version of the silver just not only translate the address of the ROM, use a different variable internal. I don't know why, but it's different. The silver FDD3 version for Timex to the FDD3 version for Spectrum.
I see. You're talking about the disk drive.
Yeah.
I see. Okay.
Yes, the reason is because I have the system since 86, 87, since the beginning. I have all the peripheral for Timex, include the joysticks in my home. That's why I have the book. I have contact worldwide, and that's I wrote the book for mathematics and also for the high school. It was very great support for use the computer, because in Argentina is the new that use a computer as a home. Normally use computer for work, but not for home, especially in the student area. Okay. But in this case, that's why I asked if was involved on the development of the adapt the system, the FDD system to the Timex. I don't know why use this different variable. I never see any reference of that in any document or whatever. I don't know, it's because all the people use FDD3 or FDD 3000 for Spectrum or for another platform. That's why never does not see these differences.
Well, for one thing, it's like super rare, that hardware. So
yeah.
For US, yes, but not for Europe.
Well, even there, I think it was rare. I think.
Well, so actually, the the Portuguese 2068 and the floppy disk systems were one way that Timex sort of recouped their losses a little bit. When Sinclair sold, when Clive sold Sinclair to Amstrad thought they were getting all of these rights to, Sinclair everywhere. And as it turns out, they did not. And one of the places was Poland. And so a deal was worked out to supply the 2068, like hundreds of thousands of 2068s, and a smaller number of the FDD 3000 systems to Poland. And so there's just a huge quantity of these things in
The
Poland.
deal was worked out and it followed through, or it was
and
worked
followed
out
through.
and never-
Yes, they made
Wow.
they made
I'm
actually
impressed by
made some money on it, right?
Wow.
Well, I don't know how much money they made, but they certainly recouped, a little bit of the loss.
And this is the American Timex or Timex Portugal?
That part is not clear to me. I mean, I think ultimately the American Timex, corporate, got the money, right?
If only we
Because
knew
it's all
someone who
Timex.
had a museum about Timex Portugal or something like that, who might know some of that.
Right, exactly. And you know what? I'm sorry, that's a good point. Joao and I did another session of our Timex connection, and I'll send that to the list and stuff. It's still about the 1500, because as it turns out, there is just so much interesting material about the 1500. And I'll give you a little spoiler here. When Timex, the folks in Middlebury, were thinking about designing the 1500, their initial thoughts were along the lines of, we're going to repaint the 1000 box, we're going to put 16K of RAM, we're just going to bump out the circuit board and put the 16K RAM basically under the keyboard, and we'll fix some other stuff. And the idea to use the Spectrum case and the Spectrum keyboard came from Portugal. As we Joao pulled up these memos, and there's this really cool memo from I can't remember the name of the person, but there's a really cool memo from one of the folks talking about how they have received this unit from Portugal, and it has this alternative keyboard, and it's got this other stuff going on, except it doesn't solve the tape loading problem. And it was just fascinating to see, you can read in the memo the shift from, we're just going to reskin this thing to, we're going to make this actually a physically different box. It's very cool. Very cool stuff.
Okay, but I don't know if Timex create or factory the Spectrum 2. Do you know that? Because I never see any product of Timex with the new case, not with the rubber keyboard. That remember the next Sinclair machine, the Spectrum 2?
No, that was, the 2 came out after Timex and Spectrum weren't working together anymore.
But not was manufactured by Timex. What is the factory of the Spectrum 2 or 128?
Don't know. Somebody else, Investronica maybe.
That's only in Spain?
I don't know. I mean, frankly, my interest in Sinclair's operations with the Spectrum drops off dramatically after 1982.
Okay. Yes, it's strange because Timex only created a single version of the ROM and the operating system, never patched the OS, and never used a different version. It's very strange that in Portugal does not ship the new Timex computer in the PAL or to Poland with the patch or ROM patched.
I think they were trying to
on
just do
that.
it on the cheap, like.
Yeah.
I was going to say, if it ain't broke, don't fix it. But I guess it was kind of broke, but they still didn't fix it. So
Well,
they're slowly
I
gonna sell it.
suspect that eventually we will get there, but there's just the vein of stuff about the 1500 is pretty rich, and we're so we're going down that, and then I think we'll start going down the 2068 path.
Yeah, maybe you can post a link to that in the show notes. Not the show notes. We
Yep.
don't have show notes. This is not a podcast, but you know what I mean. Yeah.
In the notes underneath the yes,
Yeah, exactly.
absolutely. Yes.
Okay, thank you, David.
Yeah.
So is there
Well-
anything else anyone wanted to bring up? We got 3-4 more minutes left here. We've got obviously we don't have as many people as normal, but if anyone wants to get into something before we log off here, now's the
A
time.
couple of quick things.
Yeah.
Thank you, Richard, for presenting that, especially with PowerPoint and everything. And then even though David put you on the spot, well, what does that 3-letter acronym mean? But yeah, thank you for that. And then Adam, I do like when I first saw the Frogger for the ZX81, I was blown away. I thought it was the greatest thing ever.
Oh,
So
really?
I
You
thought it was
saw it 40
very
years
cool.
ago, I guess.
Oh, it blew me away. I thought, this is great. All my friends, okay, my friend came over and saw it. And I thought, this is great. So anyway, but yeah, this has been
Oh, that's
good. I
neat.
appreciate it.
Yeah, it's also,
Oh,
yeah, maybe
and
I'll
then
take
the
another
last
look at
thing-
it just for you, Jeff K.
Oh, okay, thank you. And then the last thing, the RS-232, the beauty of it is it's, you know, in the 80s, it was used so much. So even the Mattel Aquarius that has a serial port on the back for the printer, you know, that's how some of the emulator writers got the ROM contents out. You know, they hooked up a RS-232 to, I think, a PC, you know, dumped the ROM, and then that's how some of the early Aquarius emulators were written. So there's, you know, tons of information on RS-232, and it's just kind of neat to see this, you know, project come to fruition. So
Yeah, it's really cool. It's really cool.
So the next meeting, I'm going to play Frogger for 10-15 minutes live on air. Okay?
Sweet.
well,
And
well,
that'll
okay,
include one jump.
well, yeah, you may have misread, and I have this problem a lot of times when I talk. That's why I try not to talk too much, is I say stuff I'm not sure if I was heard correctly. But I just want it on the record that I thought it was cool at the time. But
Right,
wow,
gotcha.
okay, I'll stop talking.
Oh, okay. So what you're saying is
Well, you know, Richard, I have one final question. Speaking of games, did you ever use your Timex computers for games, or your Sinclair computers for games, or were you, you know, I'm writing this book. You know,
No, I can't say I did. No.
Okay.
all right. So our next meeting is Monday, July 3rd, I believe. 9 p.m. Eastern. Yep, July 3rd. So looks like I'm guessing it's gonna be a 4-day holiday for a lot of folks. So you'll have plenty of time, Adam, to get that you know, your 1000 all set up with
Oh, for the
with Frogger, and actually get it loaded. You know.
Oh yeah, I'll start loading it today.
Yep. Mhm. Right.
Yeah.
Yeah, and you can practice making that one jump that'll take you 5.
Forget that game. I mean, I love that game. Right. It's been good, guys. I'm going to go to my book club and
Yeah.
chat up about my sci-fi book. And yeah, it's always a good time with you guys. And especially thank you, Richard, for presenting
thank
your
you.
great presentation. It was awesome.
That was
Yeah,
wonderful,
Much
Richard.
time for me.
That was wonderful.
You have any follow-up? You said you're typing in these things, so let me know how that goes.
Yeah, we're gonna play with them. We're gonna play
Yeah.
with them.
In fact, Richard, maybe David, because I have been posting we have a group on groups.io. I don't know if there's a way for you to log in. You don't even have to log into that, right, David? Yeah, you can just.
I
look at
think
the
it's
posts.
publicly viewable. Yeah.
Yeah.
I'll send you the link, Richard.
Maybe
Okay. Yeah.
David can send you a link to the thread that I've been posting some stuff in.
Yeah.
It's nothing special. You've seen it all. You ran it all. You know. It's nothing you haven't seen before, but it's being used again 40 years later. So.
Yeah.
Well,
Right. Thanks, guys.
it's been wonderful.
Yeah.
Thank you.
Bye.
See you guys
Bye.
in 2 weeks.
Bye, guys.